So our next speaker is also from University of Waterloo. He is an associate professor of computer engineering over there. And one of his passions has been making static analysis tools accessible to developers. Patrick is talking about what actually makes a good test suite today.
Thanks, Sona. So of course, as a professor, I have students, and so I have to thank Felix Fang, who did a lot of the work and a lot of the complicated numbers to find out. He did that work. I'm Patrick Lam. So the way I thought I would structure this would be to look at test cases or test suites and myths versus realities. So what we're going to do is we're going to look at 10 open source test suites, and I'm going to tell you what I could find about these test suites based on looking at them, based on doing static analysis of them, based on doing dynamic analysis of them. So let me start by talking about the test suites that we're investigating. So they come from a variety of different problem domains. They are all Java programs or libraries. We have Google Visualization, which draws graphs and charts. We also have JFreeChart in the same domain. It draws charts as well. We also have graph theory, so that's as opposed to charts, it's graphs, nodes and edges. We have HyperSQL, which is a database written in Java. We have the Commons Collections Library. We have JMeter, which is a performance testing tool. We have Weka, which does machine learning. It's a machine learning library. We have POI, which manipulates OpenOffice documents, the XML formats. And we have another tool in the XML area, the JDOM, so it manipulates general XML files. And we have JodaTime, which deals with time and date manipulations. So these are 10 benchmarks, and they all have test suites. And these benchmarks are from pretty small, 30K lines of code, to 500,000 lines of code in the case of Weka. And so we'll see this on the next slide as well, but what proportion of the code is accounted for by test cases, and that varies from 5% in the case of Weka to more than half of the code in the benchmark is accounted for by test cases in the case of JodaTime. So what we'll do is we'll start by talking about these test suite properties, and then we'll have 3 myths and the realities or misrealities that these we see on these test suites. So first of all, we can start by talking about the test suite size. And we can compare the test suite size, which you can see on the y-axis going up and down, with the x-axis, which is the system lines of code. And so I've plotted all of the numbers for our test suites here. And so what it looked like to me was we sort of had 2 groups of benchmarks. We had the group of benchmarks with not very many test suites, so here. And so I did a least squares fitting here. And so what we have is there's a there's a constant factor, but then for every line of, for every 100 lines of system code, you have about 3 lines of code, of test code. And then we have the benchmarks with more test cases. And so on average there, after the coefficient, we have about 30 lines of test code for every 100 lines of code. So these benchmarks seem to fall in two clumps. The other thing I looked at was the number of test cases, which when you run the test, it reports, I ran 500,000 test cases or whatever, versus the number of static test methods that you could look at by just basically grepping the code. And so what we have here is essentially about 1 test case per method for a lot of test cases. So this is a line. This line represents 1 test case per method. Some are below that for weird reasons, but most of them are slightly above that. And then Apache Commons Collection is way up there. It has a lot of test cases per test method, and I think I'll talk about that right now. It is a huge outlier. It does a lot of reuse. We will also talk about reuse later on in the talk, but I thought I would highlight Apache Commons Collection right now. It implements data structures, maps, trees, that sort of thing. And so there's a lot of commonality between the different test cases in this test suite. So let's look at a specific example. The specific example is test map, test flat3 map, and that contains only 14 test methods. And then when you run it, it's like, oh, I ran 156 test cases. So it's like, what's going on here? That's strange. So there's inheritance. So when you have a JUnit test, then it is going to run the tests from the superclass as well. And so beyond the 14 test methods for test flat stream map, there are also 42 tests inherited from superclasses. And then there's this thing that Apache Commons Collection has called bulk tests. So it's basically just snarf in all the tests that have to do with maps, for instance. And so it runs a lot of those tests as well. And that's where the 156 number comes in. And when you have that for all of the test classes in Apache, that's why you get this huge blow up of the number of test cases versus the number of test methods. OK, so that was the static numbers for the test suites, the sizes. The next thing I'm going to talk about is some of the dynamic numbers. So it's like how many tests, how long does the test run, for instance, and that should be the next slide. So test cases should sort of run fast. And so as it turns out, these test cases are mostly pretty hermetic. I'll talk about a bit that later. But these test cases run fast too, and so most of them run in under 30 seconds. There's JMeter, which takes 53 seconds, and then JFreeChart takes some sort of undetermined amount of time, but on the run that I report here, it took about 4 minutes. It sometimes took 7 minutes as well. So most of these test cases do run pretty quickly. So flaky tests, how many flaky tests are there? Well, these open source test suites are, I guess, pretty simple, and they do not have a lot of flaky tests, except for HyperSQL. I just couldn't run it, so all of its tests are flaky, I guess. Google Visualization has 76 out of 384, so that's high. But everyone else is really low, and so 6 of these test cases, or 6 of these test suites, have 0 failing test cases. Weka has 1 failing test case, and JRAM has 3 failing test cases. So for whatever reason, these open source projects probably have the thing where it's like, OK, you can't really commit to this project if you have failing test cases. I also went and looked for evidence that there was continuous integration, both on this slide in terms of daily builds and in terms of test suite running daily. So most of these projects do have daily builds. 7 of them do in particular. Google Visualization does not seem to be actively developed, and it doesn't have daily builds, for instance. But most of them do have daily builds. And almost half of them have daily tests. And because they're open source projects, they can get other people to contribute infrastructure to them. For instance, Surefire is one service that provides test case running for open source projects. SonarQube does, as well as Travis Continuous Integration. So there's quite a bit of continuous integration, but it's not everyone that runs it. OK, so the next part of the talk is going to be talking about various test case myths. And so we'll talk about coverage now. And so some people kind of say it's a really important thing, especially in textbooks, and that kind of annoys me, actually. So I've taught from this textbook, Introduction to Software Testing by Aman Nofut, and so I've highlighted in yellow all of the content in the textbook that's about coverage. And so I was trying to figure out how important is coverage to developers in practice as measured by the amount of effort that they spend obtaining coverage of their test suites. And of course, in the textbook, there's a lot of different types of coverage. But if you run tools, then you know that you can get branch and statement coverage. And there's also complexity coverage, which I couldn't actually understand what Eklama was measuring for that. I don't know what his definition was. But the number of definitions of coverage in the book is large. The number of coverage that you can actually measure is small. So I went and looked at the coverage metrics. And so this is the results from the 9 benchmarks that I could run, I think. And so the average coverage, I believe, I didn't actually compute what the average coverage was, but you can see what the coverage is for these benchmarks here. And so for some of the benchmarks, you can see coverage is important to the developers. It doesn't really happen by accident that you get like 95% branch coverage, instruction coverage here. For some of the others, it's really not. And it also correlates, by the way, with the benchmarks that had very few lines of code. They also have low coverage. So Weka was in the category not many tests. JMeter was also in this category. You can also see that instruction and branch coverage are pretty similar, and you probably already know this. So from my observations, it seems that developers act as if coverage is sometimes important. It's more important to some people than others. But tools only give limited data about what coverage we're getting. So I guess maybe one way to think about it is coverage is one part of a balanced breakfast or whatever. So maybe a guideline is to consider metrics beyond reported coverage results. So Weka has very low coverage, but then you look at what Weka is doing, for instance, and the way you commit something to Weka and you get it included in the main distribution is you write a paper, you write it's a machine learning toolkit, so you have machine learning algorithms, and the way you get a new algorithm into this toolkit is you published a peer-reviewed paper about your algorithm. So in some sense, the software is not validated using testing, it's validated using peer review. So that's another way of ensuring software quality. There's also, of course, coverages that are not covered by QA tools like input space coverage, and they're important too, and we should probably think about them, but they're not measured by tools, so you just have to hope that you have high input space coverage, I guess, is what it boils down to. Okay, so the first myth was about coverage. The second myth that I had in my head was tests are simple. And so I think most tests are just a bunch of lines of code that do something and then do some asserts. So I set out to figure out how complex tests actually are. And so what I did was I looked at two things. I looked at the complexity of individual test cases, and then I also looked at the dependencies of tests, networks, and file systems. So let's look at the static code complexity of our test cases. So the first thing I did was I looked at these test cases and said, how many asserts does each test method contain, or which percentage of test method contains more than 5 asserts in the test code? And so here's an example. I kind of simplified it probably a bit too much, so it doesn't actually show the right thing, but it has 5 asserts. So I looked at methods that contain, just by counting, at least 5 asserts. And so here, most test methods, the vast majority of test methods, are pretty simple and contain fewer than 5 asserts. So in particular, I believe the geometric mean here is somewhere in the 30% range. And so Apache Commons Collection has the most complicated test methods here, the highest number of complicated test methods. Google Visualization has test methods that are very simple. I believe that most of them just have they do various things, and then they have a fail call if the state is not as expected. And usually you have at least 70% of the test cases which are pretty simple. The next thing I looked at was beyond just their length, how many of them had branches, right? So if you have code that doesn't have branches, then in some sense it's pretty simple, right? It just starts at the beginning and goes through to the end. And here's an example of a test that has a branch. It has an if-else, so this actually happens. And in the if branch, it is going to call assert equals wrapped in a try block. On the else branch, it does the same thing, but it's not wrapped in a try block. Another thing I looked for is how many test cases have loops. And it's like, why are you writing test cases with loops? Well, this is one reason you might do it. It's JGraphT, which is graph theory. And so it's iterating through a set of permutations in the test case. And then it actually counts the number of permutations and makes sure that it's what it expects. And so how many test cases have branches? How many have loops? Most test cases have neither branches nor loops. So once again, I should point out that this is not 0 to 100. This is 0 to 60. And Weka has a lot of complicated test cases. So it has not many test cases. However, the test cases it does have are complicated. And 60% of the test cases it has are going to have branches, and 30% are going to have loops. In general, the geometric mean here is 5% of the test cases have loops, and it's about 20% of test cases here that have branches. So 80% of the test cases in general do not have branches, and so they're just straight line code. Some benchmarks do not have any loops at all, like JOTA-time and JFreeChart. So all of their test cases have at most branches, but no loops. OK, so that was the syntactic complexity of these tests. So most tests are pretty simple. And then the other thing we might want to know about is, what do these tests use? Do they use the file system? Do they use the network? So I did a grep, basically, about what these test cases are actually using. And so most test cases use the file system in some way. And so what does that mean? I then dug in and looked at how these test cases use the file system. And I would say they're OK. So they do things like create temporary files and then compare the temporary files against golden masters. they verify, they serialize. Serialization is a big reason that you might use a file system because you want to serialize. And even if you serialize to memory, then you still need to compare it to something. That something is usually, you could put it in your code, but that would be silly. You would be better off putting it in a file and then comparing it to a different file. There's another serialization case for JDOM. JMeter creates charts. It tests their existence. It doesn't actually, it's hard, I guess, to test that the chart actually looks like it should. And these open source programmers don't have the resources to actually test the charts are actually the correct thing, but they actually check if the chart exists or not. There's also some comparisons versus golden masters as well. Okay, the other thing I was curious about was whether these tests use the network or not. And two of these tests do use a network, JMeter and POI. And so the question is, how do they use the network? Okay, so JMeter is totally legit. It has a mirror server. It does stuff which serves files on demand. And so it tests versus a mirror server that it puts up on localhost. So that's fine. The other test is kind of sketchy, and it connects to this hard-coded URL, sc.openoffice.org. I don't really recommend doing that in your test suites. The other side, how do you avoid dependencies, is by using mocks and stubs. And in these test cases, or in these test suites, only Google Visualization used true mocks in the sense that you have an object for which you're recording expectations. There are stubs in 4 other suites, so they create dummy objects which have no functionality, but you can call the right methods. Okay, so the myth here that I wanted to examine was test cases are simple, and I think I confirmed this myth. So these test cases have very few asserts. They have some branching, but not that much. Most test cases do not have any branches. And there's some file system usage, mostly to test serialization, and some network usage, but that was pretty rare. Oh. So what I'm doing is I'm saying myth, and then reality, and then a consequence which you can take back with you, I hope. And so the consequence here is that most of these test cases are pretty simple, and they don't need a lot of high expertise to write. Of course, you need expertise to design a test system, and as we've seen here, designing whatever you want to, how do you want the test to work? That's hard, right? Designing the system, the test system, that's hard. Writing the tests themselves, if they're just simple JUnit tests, not that hard. So the tests here are pretty simple. And then you have, that accounts for maybe about 80% of the tests. About 20% of the tests are actually difficult code to write, so there's something going on for these tests. Okay, the last myth I want to investigate is how do people write test cases? Do they leverage a lot of reuse? Do they leverage a lot of subclassing? Let's talk about the different types of reuse that people might use when they write tests. So you might have, for instance, in JUnit, you might have setup and teardown to set up a fixture. You might have inheritance, which Apache Commons Collection uses a lot. So you might have related test classes building, subclassing the same parent class. Or you might have composition. So you might have these classes which are used by multiple test classes to perform tasks. And so I investigated each of these types of reuse. And so setup and teardown, it's again varies by test suite. JotaTime, almost every test case does use setup and teardown. That's just the way they set up their code. In most of the other cases, setup and teardown is not consistently used. So JFreeChart, JGraphT, and POI use about 10% of test classes have setup and teardown. For the other classes, there's maybe about half of the classes that use setup or teardown. So it's there, and it makes sense for some tests. For others, it may make sense and they're not using it. I don't know. Inheritance is heavily used in 4 of these test suites. And so in these cases, 50% of test classes inherit functionality from some other test class, some abstract test map, for instance. And so we can see here again, it varies in Apache, SQLDB, JMeter, and Weka. Most of these test classes are going to inheritance functionality and use these, the inherited functionality. In a lot of others, they just always inherit from JUnit test case. The next thing I want to look at is helper classes and how many of these classes use helper classes. Here's an example of a helper class. So you have this helper class record inspector, which is just going to return this list of records. And so I just went and counted the number of classes that looked like they were helper classes. And this is a relatively small number in terms of the total number of classes. So there are some, at most, double-digit number of helper classes. I think what I can deduce from that is that most of the functionality of a class is going to be located in that class itself and not elsewhere. So classes are mostly self-contained, either in that class or in that class's superclasses, as we saw on the previous slide. One thing I looked at was test cloning. So another way of doing reuse is by using the cut or the copy command and the paste command, right? That works pretty well. And so what I investigated here, Divam Jain started this work, and then we continued this work with Felix. How many test classes appear to be, or how many test methods appear to be test clones of other methods? Here's an example of test clone. So you have these two methods in Weka, I believe, and so they're basically identical except that you replace nominal in the first method with string in the second method. And so this is a form of reuse. How often does it happen? Let me talk a bit about the way we discovered test clones in our test suite. So the insight here was that assertions were key to detecting what a method does. And so if two test methods have the same set of asserts, then they are going to be likely clones. And so we looked at the assertions and how they worked in the control flow graph to determine likely clones in the test suites. And so the incidence of cloning, on average, 40% of test cases look to be clones of other test cases. I also did some manual classification about how the false positive rate was. And most of these are actually not false positives. They are actually legitimate clones. I think it's like 75% of these are actually clones. So it's all about the same, except for Google Visualization. It has very few. But for most of them, it's somewhere in the 40 to 50% range of test methods, which are clones of some other test methods. OK, so you have this test cloning thing, and maybe that's not so great, and maybe you'd like to refactor your tests. What can you do? Well, you can use setup and teardown, which some test methods do. You can use subclassing, which some of our test suites do. JUnit 4 has, not many of these test suites actually use JUnit 4, but if you did use JUnit 4, then you could parameterize your unit tests. So you can specify, I want to run this test over this data, and this data, and this data. And it'll run the same test method over all this data. There's also notions from the research like test theories. Apache Commons Collection, like I said before, it was weird in the sense that it had some disproportionate number of test cases compared to the number of test methods that we have. And so it has this notion of bulk tests. And so what's going on here is that you can run a predefined set of tests, and you give it a test object, and it runs all these tests on this test object. Another way of getting reuse is by having automatically generated tests. And that's kind of like parameterized test. It's another way of doing that. For JDOM, what happened here was that they have a grammar for whatever they have, and then they generate tests based on the grammar as well. They actually only generate stubs, not the actual tests. So how much automatic testing technology? Well, you of course run the test automatically, but is there automatic test generation technology? In our suites, we didn't find a lot of it. So what I would say is that the principal automation technology was copy and paste in these test suites. So the reality is that automated test generation is uncommon in our test suite. So it looks like people generated these tests by hand. So I can suggest maximize reuse. You can use setup, teardown. You can use inheritance. You can use parameterized tests. Whatever works for you, there's a lot of options. If you think it's a win to get more maintainable test suites, you can consider doing your tests that way. So some examples of test generation tools are Korat, which allows you to generate structurally complex tests, Randoop for random testing, and fuzzing. We also heard yesterday about the Chrome fuzzing test work as well. So you can definitely fuzz your tests. So I can summarize with the 3 myths. So coverage is a key property of test suites. Yeah, maybe. I guess so. It's sort of important. Tests are indeed simple, so I think I can confirm that. And tests are written by hand. Thanks. I will take questions now. Oh yeah, all the data, if you want it, is on the slide as well. Like, you look at it.
Any questions? Anything on the moderator line? Great. Thank you very much, Patrick.